So what is the average fixed cost? The average fixed cost is simple. It is equal to average fixed cost means average fixed cost per unit produced. It is equal to total fixed costs over divided by the level of output. Okay, so here we have the quantities, the different levels of output. The fixed cost is fixed at $100. So the average is dividing 100 by the number of units produced. So the fixed cost is the average fixed cost is AFC, is fixed cost divided by the quantity of output. So we see that it is at the beginning it is 100 for the first unit, and then it is 50, then 33.33, 25, 20. It is always decreasing. This is obvious because as the denominator Q increases, as the ratio would decrease. So notice that AFC falls as Q rises. The firm is then spreading its fixed costs over a larger and larger number of units. So it is good that we produce more than less, because producing more makes the average fixed cost for each unit lower and lower. And this, of course, will, to a certain extent, lower the total cost per unit. So here, if we trace the average fixed costs curve, we see it is a curve that is going always downward. Now the average variable cost is the same definition, but instead of the fixed cost, it is the variable cost divided by the quantity of output. AVC is VC over Q. Okay, you see from this example, it is for the first unit, it is equal to $70, then 60, then 53, then 0.33, then 52.55. So you see it is for the first 4 units, it is decreasing. Then from the 5th unit, it rises to 56, then 63.33, and for the 7th unit, the average variable cost is 74.29. So the average variable cost, unlike the average fixed cost, it is not going downward all the times, but only for a short period of time it goes downward, but then it goes upward and increases as the number of units produced increase. So as Q rises, AVC may fall initially. In most cases, AVC will eventually rise as output rises. So this gives us this shape of the curve, the average variable cost curve. It has this shape. It looks like U-shaped curve. It has the form of U. So the average total cost is equal to total cost over quantity produced, quantity of output. It is also equal to, if we divide, it can be, if we put total cost as equal to fixed cost plus variable cost, the average total cost is equal to fixed cost over Q plus variable cost over Q. So the average total cost is equal to the average fixed cost plus the average variable costs. So you see here, we in this table, we compute the average total cost. For the first unit, the average total cost is 170, then it is 110, then it is 86.67. For the fourth unit, it is 77.5. So it is initially it is decreasing, but from the fifth unit and the sixth unit and the seventh unit, the average total cost rises again. So it is like the average variable cost. Initially it decreases, but then eventually it rises again. So the ATC curve is also U-shaped curve. Okay, so it has in this plane we draw the average total cost curve, and as you see, it is U-shaped. So here the green curve represents the average total cost. The blue curve represents the average variable cost curve, and this dark blue curve represents the average fixed cost curve. And this orange colored curve represents the marginal cost curve. Please note that the average, the marginal cost curve, first it declines, initially declines, then it rises again. And note that the marginal cost curve crosses the average variable cost at its minimum and crosses the average total cost at its minimum. This is an important observation, an important lesson we learn from drawing all curves in the same plane. Please, you have in this slide these small exercises, and you are asked to complete this table. You can use the data you have to complete the missing variable cost, total cost, average fixed cost, average variable cost, average total cost, and marginal cost. So why, the question is, why the average total cost is usually U-shaped? Why, in other words, why the average total cost declines at first, and then after some time, after certain limit of production, it rises again. We can, from when we look to the curves all together, we can understand why. Initially falling average fixed cost pulls the average total cost down. So this first decrease in the average total cost is the result of the falling average fixed cost. You know, the average fixed cost, as we increase the number of units produced, the average fixed cost decreases, and this decrease in the average fixed cost which is a part of the average total cost, make the average total cost fall down as well. So it's this decline in the average total cost is at the beginning, it is actually the effect of a declining and falling average fixed costs. However, this decline does not go forever. in this example, this average fixed cost effect does not stay longer than the fourth unit produced. After that, when we remember from the data that after the fourth unit, the average variable costs start to go up, start to increase. And this increase in the average variable cost, which is a part also of the total cost, of the average total cost, will pull the average total cost up. Okay, the effect of the average fixed cost is no longer significant, and it is compensated by the variable costs effect, since the variable costs are now average variable costs are now increasing for each unit produced after the fourth unit. The effect of this increase in the variable cost will not only absorb the effect of the downward average fixed cost, but also it will rise the average total costs. It is so important that it absorbs the decreasing effect of the average fixed costs, of the declining average fixed costs. So that is why both effects, now after the fourth unit, the effect of an increasing average variable cost is so important that it pulls up the average total costs. That is why the average total cost curve is U-shaped. It has a form of U. So efficient scale, we call this efficient scale is the quantity that minimizes the average total cost. So here the curve is of the average total cost is having its minimum when the production level is 5. Okay, at 5 units, the firm here is producing at its lowest average total cost. Example 2, we draw again the average total cost, the marginal cost. So here you see in this example 2, you see that the marginal cost curve in orange color crosses the average total cost curve at its minimum. So here the marginal cost is somehow an indicator. It tells the firm what is the level of production that makes her producing at the lowest average cost. So you see, when the marginal cost is lower than the average total cost, means the marginal cost curve is below the average total cost curve in this area. The average total cost is falling. When the marginal cost is higher than the average total cost, means the marginal cost curve is above the average total cost curve. We have the average total cost curve becomes rising. So then the MC curve crosses the average total cost curve at the average total cost curve's minimum. So here is the minimum. And the marginal cost curves tells us about the location of the average total cost curve's minimum. And at this minimum, here at this minimum, it corresponds the level of production that the firm can produce and to which it can get the lowest average total cost per unit produced. Okay, now, how about the behavior of the costs, of a firm costs, according to the time, short run and long run? Indeed, there is a difference, or slight actually, difference between the costs, whether we look to them in the short run and or in the long run. The difference is that in the long run, all inputs are variable. This means that all costs are variable. In the long run, we don't talk about fixed costs. All costs become variable. Example, firms can build more factories or sell existing ones. So it does not have only the cost of the factories is changing. The cost of a rent for a factory is changing over time. So we cannot talk about fixed rent in the long run. It will be considered as variable. The cost of a land, like in Farmer Jack's example, it is also variable. The size of the land might change. The farmer can whether buy more lands or sell some existing acres of his land. So the costs that related to the fixed costs the fixed costs of the short run will become variable on the long run. So in the long run, we talk about variable costs. All costs become variable. So in the long run, average total cost at any Q is cost per unit using the most efficient mix of inputs for that Q. So what we are going to do here is to draw the average total cost curve in the long run. Okay, the average total cost in the long run. Example, we'll see this example, the factory size with the lowest average total cost. So the LRATC means long run average total cost with 3 factory sizes. So in the y-axis we put the average total cost, and in the x-axis of this plane we put the quantity produced. So firm can choose from in this example 3, firm can choose from 3 factory sizes S, M, L, small, medium, and large. Each size has its own short run average total cost curve. In the blue curve, it represents the short run average total cost curve for the small size. This green curve represents the short run average total cost curve for the medium size. And this curve in purple color represents the short run average total cost curve for the long run. Excuse me. So the firm can change to a different factory size in the long run, but not in the short run. So in the long run, a firm can change to different sizes. So the firm will choose a size in order to lower or use its mix of inputs that make her producing at the lowest average total cost possible. So to produce less than QA, firm will choose the size S, small, in the long run. So if the firm is producing less than QA, it is better that the firm choose the size S, because at the size S, the average total cost corresponding to this size is the lowest possible. If the firm wants to produce between QA and QB, the firm will choose size M in the long run. Why the size M? Because at the size M, the firm is producing at the lowest average total cost. If the firm would like to produce more than QB, so the firm is better that the firm choose the size L in the long run. So joining together all portions of these curves all together, we get all portions of the three curves that make the firm producing at the lowest average total cost. We get what we call the long run average total cost, which has this form, this special form, and it is represented by this orange curve. Of course, in the real world, factories come in many sizes, each with its own short-run average total cost curve. So instead of only three sizes, there are many sizes, like here. If we do the same work we did in the previous simple example, we get this typical long-run average total cost curve that look like this orange colored curve. So we get this curve that represents the long-run average total cost curve. At the beginning, you see that the long-run average total cost curve is falling downward as the quantity of output increases. We call this phase as the phase of economies of scale. Economies of scale when the average total cost falls as Q increases. Then the average total cost becomes constant as the quantity produced increases. And we call this phase the phase of constant returns of scale to scale. Constant returns to scale. And then after certain limits and a certain level of production, as the firm increases its output, the average total cost rises. And this phase is called the phase of diseconomies of scale. So here we defined economies of scale and diseconomies of scale and constant return to scale. So in the long run, at the beginning, the firm can benefit from the economies of scale, and these economies of scale makes the firm producing at lower costs, and producing at lower costs makes the firm more competitive in the market because it can sell at lower prices. So it is good that the firm try to benefit from the economies of scale. Then this economies of scale is not something eternal. It comes to an end, and after a certain level of production, of output, raising output would not bring a decrease in the costs. At the opposite, it makes the firm producing at a higher costs instead, and the average total cost increases. So the behavior of costs is always U-shaped. Initially, it decreases, they decrease, then they become maybe constant for a certain period, and then they rise again. So it is primordial and paramount for a firm to know when it has economies of scale, so it can benefit from them. Economies of scale occur when increasing production allows greater specialization. So why there is, what is the background explanations for these economies of scale? Actually, they might be explained by the greater specialization of the firm. Increasing production means greater specialization. Workers become more efficient when focusing on a narrow task. So they are doing the same task every day. The work is not called to do many tasks at the same time. No, there is specialization, and this specialization makes the worker more efficient. And because the worker is more efficient, the costs of production will naturally decrease. This reminds us the example of Ford, who the American entrepreneur who used specialization to produce cars at lower costs, and by producing cars at lower costs, he could sell the cars to a large number of customers, because the customers, and at that time, American customers and cars and American customers and American middle class customers became able to buy cars and to drive cars, because the firm Ford could use specialization to decrease the cost of car production and make it affordable for an average American. More common when Q is low. Okay, these economies of scale are due to coordination problems in large organizations. So as the quantity of production increases, the size of the firm increases, it will come a time when the coordination in large organization becomes problematic. And when it becomes problematic, the management becomes difficult, and when the management becomes difficult, there will be difficulty to control the costs, and that is why the costs rise again. This rise in costs is due to the problem of coordination in large firms. And if there is a problem, like in coordination, the control of costs will be very difficult. And if the firm is not able to control its costs, the average total cost will rise. That is why this economies of scale happens after certain large level of Q. Conclusion: costs are critically important to many business decisions, including production, pricing, and hiring. This chapter has introduced the various costs concepts. The following chapter will show how firms use these concepts to maximize profits in various market structures. So we'll understand better the use of these different concepts of costs in the following chapter when we study the behavior of a firm in a competitive market and how a firm in a competitive market can maximize its profit. So here we come to the conclusion of this chapter, and we conclude this chapter by summary. So in this chapter we have seen different types of costs, notably the cost implicit and explicit costs, and we have seen that economists see costs more profoundly maybe than an accountant, because they do not stop at explicit costs, but they include to them the implicit costs, like the opportunity costs. So here we will necessarily have two different profits: the economic profit and the accounting profit. The marginal cost is an important, I think it is the most important concept in this chapter, and because we will need it in the coming chapter. The intersection of this marginal cost curve with the other curves can tell us when the firm can produce at the lowest cost, average cost possible. So I have finished with a very short chapter. I hope it was very clear. Mostly it is about definitions and about shapes of curves and about evolvement of different curves. This understanding them is very important to understand later how a firm can make a good decision about its level of output, about its production, about the level of output that makes her making the highest profit possible, means maximizing its profit. Well, it's okay for now, and thank you very much for your attention. See you in the next video.